10.3 stretch parallel to the y-axis. Now, again, we use a similar graph now. Let's take a look. Y equals x2 plus 10. We can use any graph in the world, but for simplicity, I give a cubic graph. Now let's see if I replace y with 2y, what happens? Again, let us focus on the how. Don't focus on the n number. Look, if x goes to 3, of course you get 27 plus 10, you get 37. And on and on. Now, if I substitute the same x goes to 3 here, I'll get 37 on the right hand side. What should then be my y? Is it 37 times 2 or is it 37 divided by 2? Divided by 2, excellent. So similarly, if I substitute x equals to 0, I get 10. My new y will be 10 times 2 or 10 divided by 2? Divided by 2. So very quickly, you should be able to fill up these three numbers. And you realize that by replacing y with y, 2y, all your y coordinates are divided by 2 instead of multiplied. You follow what I'm saying? Yes? So let's make that observation. So in general, so now I quicken this process. Okay, I don't go through all the wordy stuff anymore. Now it is A. Now you replace y with AY. What happens? Just now I replaced y with 2y, right? You realize that by look here, if you look physically here, what happens? All the y coordinates are multiplied by half. That means you essentially, in a way, to put it in a very layman language, you actually compress your y in this, like this way. But think about it, it's actually multiply all your y coordinates by half. So you are actually stretching the graph parallel to the y-axis. You know what I'm saying? For the example that when I replace y with 2y, I'm actually stretching it parallel to the y-axis, but I'm stretching it with a factor half. So by stretching with factor half doesn't make it longer, it's just compressing. You know what I'm saying? So, what is this factor? Is it A? Cannot be A, right? Because if it's 2, my factor is half. If it's A, my factor should be 1 over A. Very good. So parallel to the y-axis, 1 over A. I'm going to explain what is the x-axis invariant. What does it mean for when I say x-axis invariant? That means, very good. Some of you say, very accurately said. That means when I stretch parallel to the y-axis, whatever points on the x-axis will not transform, will not change, because you're stretching like that. Imagine it's the center of the stretch. You put a rubber band and you hold the rubber band at the x-axis. You follow what I'm saying? And then stretch. All the points on the x-axis will not stretch. Will remain. Right? And then all these points, any point hk here will become h k over a. Very good. Well, I just explained invariant line, so you all can copy and you know what I mean. Okay. Okay, I'm going to pause here for about 1 minute or so. Okay, think to yourself, digest this part. If you need to discuss with your friend next to you, then go ahead. Okay, only 1 minute. Okay, think to yourself. This part, digest a bit.